Hello, everyone. I'm super excited to be here with Cameron Purdy and Brandon Phillips for a 25-minute discussion on a number of key topics that I know everyone listening is interested in. Cameron and Brandon in some ways need no introduction. They're very famous in what they've done in their past in the industry. But let me quickly ask them to introduce themselves and talk a little bit maybe about what you've been up to in the last couple of years. Cameron, let's start with you.
Thanks, Reza. Cameron Purdy. I am currently with a startup called Exquisite, where we're building serverless cloud infrastructure. Still mostly under wraps, but more and more of the open source side of what we're doing becoming visible on the Ecstasy language site. Previous to that, I was an executive at Oracle, which is where I met Reza in my tenure there. And Oracle had acquired a startup that I was involved with that was called Tangasol. We built the Coherence product, which is used by quite a few companies around the world. So that's a bit of my background.
Thanks, Cameron.
Brandon Phillips, formerly the CTO and co-founder of CoreOS, and helped to originate some of the key pieces of technologies at CoreOS that kind of make up the ecosystem of Kubernetes. And then in the last couple of years since the acquisition of CoreOS by Red Hat, essentially helped to ensure some of the open source communities that we had built at CoreOS remained sustainable long term. So recruiting people and showing how to keep the projects running. And then in the last few months or so, been playing around more with the idea of transparency logs and how those could help improve web and cloud security.
Great. Thanks, guys. Let's just dive right in. And I was hoping to discuss the topic of microservices with the two of you. Our industry sometimes tends to sort of grasp to something and consider it the holy grail of how something, problems are solved. We've all been through these different phases. Cameron, you remember the whole EJB phase where it doesn't matter what the question was, the answer was you got to write it in EJBs. We can probably come up with a number of other examples where this has happened, web services and so on. And now, a lot of people I talk to, they are in the middle of transforming into microservices. They're taking their applications and building separate remote services to talk to each other. And there's always this dynamic that comes in when you are taking a system and bringing it into multiple different processes that need to communicate. That seems to be a reflection of trying to abstract the way people work versus how the system should really be designed and best work. So with that in mind, what is your thought about whether microservices are a good thing in general, whether people should be doing that kind of transformation or not? Anything you can tell us about this? Brandon, maybe you take a shot at it, and we'll go to Cameron after.
Sure. I mean, I think there's essentially three major reasons people adopt microservices. One, it's trendy, something cool to put on your resume. I think there is a lot of the organizational thing. Like once application gets to a certain size, you just have to start breaking the architecture a little bit up, because every team's going to have their own idea of stability and deployment pipelines and language choices. So those sorts of organizational concerns come in. And then I think there is a legitimate case for resiliency of a system. And I mean, at CoreOS and new things that I've been working on, it is pretty convenient when you have a piece of functionality that is totally fine to be degraded by days or minutes or hours, and have those pieces of the system pulled out, so that if you screw it up or you need to modify the code or you run out of resources, it doesn't take down the rest of the system. So yeah, I think there are legitimate reasons. I think in a lot of cases, when talking to former customers or people who are doing it, they might jump into it a little too fast before considering the why, though.
Interesting. But isn't there a case to say that remoting of services makes them more complicated, and why not just decouple them as if they were part of the same process and think about decoupling as interfaces? Cameron, maybe you can shed some light on that.
Well, I think Brandon touched on the evolvability aspect, the need for an organization to be able to incrementally, add to what they're doing or change, some piece of it without having to change everything at one time. And so, if you compare and contrast between a purely monolithic architecture and a purely microservices-based architecture, you see that the one needs to be evolved as a whole and the other evolves piecemeal. And you almost never find one extreme or the other, because each extreme is fairly painful to deal with. On the microservices end of it, anytime you have a state that's managed in the application, which is pretty much 100% of the time, the more microservices you have, the more complexity you have in terms of sharing and coordinating state. At the other end, it's really easy to deal with state if you have a one process, monolithic application, because it's all in one place. But your feet are in cement at that point because you just can't move very well. So it's about, how do you find the correct fault lines in order to be able to take a large system and break it down into digestible, manageable pieces, and at the same time, how do you avoid some of the pitfalls around the complexities, keeping those things in sync.
Got it. Interesting. And talking about fault lines, I mean, is that more of an art or is it more of a science to find the fault lines between these services and how they should be abstracted and how they should be decoupled to?
Yeah, it's certainly a science to it in terms of the dependency analysis and understanding the domain well enough to appreciate which pieces of the application are going to depend on which parts of the state. But there's also an understanding of what coping mechanisms you'll have available for the inevitable fact that there will be some information that's required to be shared in some form across multiple services.
Great. Before we leave the microservices topic, Cameron, the programming language that you've been working on, tell us a little bit maybe if it has an opinion on the question of services and microservices and how that brings everything, how it brings it into the fold.
It does, but it's a little bit unusual in terms of its connection to this topic, in that we view microservices as being a brilliant approach to breaking things down into small pieces, and so we actually incorporate that concept into the language itself. But yet it's not actually trying to solve the microservices problem that you have in the wild, so to speak, where you have where you're building many different services. So I think it'll obviously be able to be used for that type of thing, but while inspired by it, it doesn't just solve it automatically.
Very cool. Let's shift topic a little bit. We talked about statefulness and how almost every service has state. I'm going to bring a wild one here. In some ways, it feels like, first of all, that almost everybody's either on Kubernetes and moving to Kubernetes, although I know that's not really true. There's still a lot of applications that's not on Kubernetes, but definitely the momentum is there. And a lot of times I hear, well, Kubernetes is great for stateless applications, but not so good for stateful applications. And Brandon, how does that change? I mean, given what Cameron was also just talking about, that almost every application has state. So what does this mean for moving to Kubernetes with all these services that actually have state and you have to manage state? Is that a good fit there? And have we solved that problem?
Yeah, I think it I think that problem kind of just goes back to the early days of Kubernetes. Like the team was just extremely cautious about running workloads, and a lot of the APIs for like managing state and file systems and stuff weren't there. I think today it's not a problem to run stateful workloads, and I think in a lot of cases people just they don't even look at the reality of their own architectures. Like almost all customers that I remember ever talking to, all their state is either in an object store or a remote NFS filer somewhere or in a database somewhere. And so their application actually is stateless. Like it's a different team or a different organization managing the state. So, and those sorts of applications are totally fine on Kubernetes. I find it very rare that, the infrastructure where you're running the API servers or whatever actually are co-located with where those API servers are storing their data. At least it's been a very long time since I've seen people like, actually writing to disk locally or anything.
Cameron, any thoughts on the question of state and Kubernetes?
Yeah, it's interesting what Brandon was saying, and quite often what you see is this evolution of an application where it begins with everything owned by the application, and over time, more formalism comes into play, and the database becomes its own realm and its own, it ends up with its own dedicated team for managing it and so on. So you definitely see some of that. And I think the, state has always been one of the most challenging parts of our industry, managing state, which is, speaking of Oracle, where we met, that's why it's been such a great business. So many people need help, managing state, right? I think how does an organization deal with that state as it grows? How do they deal with the evolution of their organization? How do they transition from a point where the application owns a state to where it's more centralized, and then how does that translate between their own data center and running that in the public cloud? Those are I think the challenges that the companies are continuing to face and deal with.
Very interesting. Let me tackle a question that I think you are very well positioned to answer, both of you. If you think about abstraction of services that an application needs, and where we were maybe 10 years ago, maybe plus, with the JVM and Java EE containers providing a container that has everything you need, and then the application basically runs on the container, and the container is really that JVM in between the operating system and the application, to where in the current world, in some ways, the container, the containerized infrastructure container, the Docker container, is serving that purpose. And in some ways, we've sort of, it feels like we've given up on the idea of a JVM layer, and we're just saying, just put it in this micro open operating system, and then bring every dependency that you have and go there. It feels like we've traveled a journey, and I'm not sure if we've gone backward or forward on that journey. What are your thoughts on that?
I mean, my thoughts as somebody who started a career in the Linux kernel is it's like the ultimate triumph of the POSIX and like Linux syscall interface. Like essentially, I think Java tried to abstract something away, tried to protect your application from the operating system, and then Linux, just that syscall interface became so ubiquitous and so widely adopted in the industry, it kind of removed any values that JVM could provide. Not to say that all the value, but a lot of it. And that coupled with so much experimentation through like the late 90s and 2000s in different languages that weren't on the JVM and were getting quickly adopted, I think it sort of made something like Docker inevitable, to package up those applications in a way that was separate from the way that the Linux distros were actually training people to package up the applications.
I think one of the interesting things is that, what Kubernetes proves is we never take out the trash, right? It's like, we're just collectors, right? It's like, oh, JavaScript, sure, I'll keep that. Java, yeah, why not? Let's take that too. Oh, Linux, yeah, we'll take Linux. Let's take one of those, two of those. We'll throw some Python in there, and it's too bad that they used the term tarball so many decades ago, because if they hadn't, we would have just called Kubernetes a tarball, right? Like, it is the ultimate collection of everything, good, bad, and otherwise. It is almost like just the end state of chaos, if you will, both good and bad. So
Interesting.
I started my career in networking, and I find it just hilarious that we have now like the hardware accelerated 1500 maximum transition unit, like accelerators. And it's just because like the internet is just built on 1500 bytes, and like you're just never gonna you're just never gonna get rid of it. It's in the DNA now. Like that's how packets are switched.
Is Kubernetes going to be in the DNA, do you think? Back when we were working together, Brandon, I remember, people telling me they're actually putting Kubernetes on things like satellites or airplanes, and when I asked why, because they had like 2 processors on the thing, the answer was more like oriented towards, well, it's the way we do things. It's just the kubectl, and the way we deploy is kubectl, and why not? It wasn't about what Kubernetes actually does, which in some ways is about resource scheduling. So is Kubernetes with us now for forever, do you think, or how's that going to evolve?
I think it'll be here for a long while, and I do feel it fits that niche of the Linux. The lower levels of the Linux stack just never bothered to define what a container was, and so Kubernetes, for better or for worse, made the definition. And so I'm sure that we're going to have all sorts of, fast forward 10 years from now, we're going to have like, lightweight system D init processes that implement a subset of the YAML parser for Kubernetes for embedded systems. I think it's inevitable, because it's a language for expressing those sorts of constraints and restarting services, and whether a service is healthy or not. And it's become kind of what used to be like an init process role. It's kind of redefined that, I think, in a lot of ways that make a lot of sense and are a lot more user friendly.
in a sense, it's an indictment of software engineering in the total, in that, Kubernetes should have never had to exist. Like, it's almost the fact that it does exist proves that as computer scientists and as an industry, we did a whole bunch of things wrong. At the same time, it's one of the most amazing pieces of engineering that we've ever witnessed. So it's like, it has to exist because of all that mess that we should have cleaned up. So I like to think of it as a, the same way after a holiday, you have these giant plastic things that you shove everything in until the next year when the holiday comes along. Kubernetes is our giant plastic container methodology. It's how we avoid having to deal with all the messes that we've created over the past several decades.
Great analogy. Yeah, that's nice. Very cool. Very cool. Let's shift topic a little bit now. And the topic that I know is hot out there is, how sticky are the cloud providers and their services, right? Some argue that we're entering a new mainframe era, where like everything you're building is now based on all these cloud provider services, and they're just so sticky. Something like Amazon Lambda, not to pick, but something like that can be quite sticky, right? And once you've written your whole application, thousands of lines of code in that, how are you going to have a chance of portability? How much of a problem do you all think that is for us today, and how much should we pay attention to it?
Yeah, I think Brandon's earlier comment on Java in the late 90s is kind of prescient here, because it's a very similar metaphor that we're looking at the early stages of now with the cloud. I mean, what do you think about that, Brandon?
Yeah, I do think it's it's just this constant struggle between investment of time for that abstraction versus the business value of just getting something shipped. And so I think it'll be an internal struggle. I mean, at the time, I feel like JVM defended itself because there was some unknowns in like what the server CPU architecture would look like. So that intermediary layer is valuable. And I think some organizations do find value in intermediation between them and the clouds, but it is hard to defend, like writing an application and trying not to let little things creep in. It's hard to defend that business value.
And at the same time, I mean, you can imagine that the vendors today are every bit as sticky and locking in as we were in, say, the early 90s, where people were either writing for Windows, or was there anything else? I mean, there were a few other
Win32, yes.
tiny bits of the market, but I mean, it was 90+%. It was definitely a monopoly.
I think one of the other things, like where it is pretty easy to defend the value of abstracting yourself from the cloud, is it's so expensive to have developers coding directly against the cloud. Like if you give every developer a cloud SQL database and their own GKE cluster and everything, like you're easily getting to thousands of dollars per developer per month and just infrastructure for them to like do their dev work. And so I do feel like there are some defensible business reasons to at least make things possible to run on developers' workstations or in smaller environments.
Yeah, and it just seems so tempting, isn't it? I mean, when you're building in the architecture of a solution that you're about to provide, you can make choices where you are going to run your own thing in the architecture, or you could just use that service, and it's right there.
Well, and there's a huge cost. There's a huge cost to the application developer in trying to abstract away from vendor lock-in. So I mean, it's until it's easier for an application developer to avoid lock-in than it is to take advantage of lock-in, applications are going to be locked in. That's just the natural consequence of the high value that is existent in the services being provided by cloud providers.
Yeah.
It's natural.
Yeah. I just had a flashback. I remember, Cameron, you'll probably remember this. Do you remember a library called RogueWave?
Yes.
I remember using RogueWave, and it had things like RH-map.
I assume you mean RogueWave for C++.
That's right, for C++,
yes.
And like RH array. And I had written all against the RogueWave library, my code. And a contractor came in and he was like, you guys are using this stuff directly. Your code is completely attached to RogueWave. You should abstract everything away. And in some ways, this is kind of the same type of thing. Yeah, I didn't abstract it because it would take forever to do that. And yeah.
Yes, I remember RogueWave well, and I remember not liking it.
And so much so that you went and wrote your own distributed mapping solution, right?
There you go.
All right. Well, hey, we only have a couple of minutes left. Let me talk about completely different topic now. You both have founded your own companies. And nowadays, everyone talks about company culture and how important that is. I wanted to talk to you about how much we thought about company culture deliberately how much of it was part of your thinking when you were building your companies and making sure that that is something that's healthy and designed. Yeah, what are your thoughts on that?
I mean, there's a lot of aspects of culture that are important. I think one of them that I remember specifically thinking a lot about is leaders' responsibility to create urgency in an organization. It's particularly when you're originating technology, it's really easy to focus on the technology and not have the next goal in mind of either showing to the customer or getting out that next blog post or that sort of thing. So we spend a lot of time through just focusing on shipping and creating milestones for the team that help to create that momentum. Because I feel like organizations, they just like people, they get excited by momentum, and creating that is an important part of building a company.
I'll ask a follow-up on that quickly before Cameron, your take on it. What about the difference between momentum and urgency? Because I think there's two different things in some ways, right?
That's true. I think that momentum is like, it's where you have success after success after success, and that helps to motivate people. And urgency, we always thought about as dates where you were trying to hit in order to continue that momentum, And so, but it can be small things, like it's not necessarily deadline driven. It's, can we have an internal company demo? Can you, by Wednesday, can we try to show this to the team next door? Those sorts of things. And so it's big and small moments that I think help the team celebrate what they've done.
Yeah, generally, your team is going to be working on a goal that they can see, that's kind of within the grasp, so to speak. And I think one of the things Brandon was highlighting is that you have to be thinking about what's the thing beyond that, and then the thing beyond that, and you have to be, sometimes you'll hear people say thinking strategically, but it means, not just going from point to point, but actually picking a point far out in front of you and then choosing points that are between where you are and where you want to go. So there's achievable goals in the meantime, even if not everyone understands what the long-term point is of all the short-term goals, they can understand and appreciate the short-term goals and kind of feel the closeness of achieving them. And then the other thing you asked about, the urgency. There's a couple great articles online. I don't have a link offhand, but on the difference between important and urgent, right? And quite often, companies, big and small, get into the habit of focusing on the urgent and ignoring the important. And it's so easy. It's what I call fire drill mode, right? Everyone loves fire drill mode because it's like there's this terribly urgent thing. Let's get everyone working on it. Let's get it fixed, and then we can give each other high fives and yay, we fixed it. And the urgent things can block out all the important work, and they are so interruptive. I don't even know if that's a word. So interrupting that they can destroy any R&D cadence. They can destroy anyone's concentration. They can, over time, just erode people's focus. And so, being able to focus on long-term important goals and to find ways, even if they're artificial, to reward people for choosing to do the important, choosing to do the things that have lasting value instead of going for the sugar rush, the high, if you will, of doing the urgent, where they get this instant reward. So that's really important, I think, when you're building a culture of value.
Yeah. Here. And we can probably say that a lot about our day-to-day life as well nowadays. Yes.
of course.
Very
Sure.
cool. Hey, I'm going to wrap it up with just one question from each of you. What would be the advice you would give a younger version of yourself right now? Perhaps listening, perhaps thinking about the next distributed key value store technology to be building that goes beyond etcd and coherence. What would you tell them?
Go ahead, Brandon.
Yeah, I think early in my career, I beat myself up a lot about having to dig in and maintain old broken systems, which was like kind of my role as a Linux kernel engineer. And but that having that like depth of understanding, particularly of older systems that you didn't originate, that were built before you, and having that skill set of essentially like computer science forensics, like why does this exist? How did it even work in the first place? Was way more valuable than I ever would have imagined. And I always felt like I was wasting my time at the time, but in hindsight, it's one of probably the best technical skills I picked up.
I guess if I had to pick one tiny bit of wisdom, I would say, the people that you see in the industry who are successful and doing incredible, the distance between you and them is tiny, it's minuscule. Just a couple of years ago, they were you. They were in your shoes. They had no idea what to do next. They had no network to rely on. They had no experience negotiating with VCs or closing a round, or they had no idea what to do. They had never served on a board, never had a board, and now you look at them and you see the success, but what you're missing when you look at that is how little separates where you are from that type of success. So sometimes, you just have to take a step of faith of, of course you don't know what you're doing, but that doesn't mean you have to stay where you are. Be willing to experiment, be willing to make mistakes, and be willing to fail. It doesn't mean you're going to fail. It doesn't mean you have to fail, but be willing. Don't worry about not knowing what you're doing. Sometimes that's the best place to start.
Great.
Yeah, great advice.
Yeah, good advice. Thank you. This has been an insightful discussion. Really appreciate both of your times, and good luck with your future endeavors. I know there's more great things coming up from both of you, so looking forward to seeing them. And now we're ready to take some questions. So please ask your questions, and we'll do our best to answer them. Thank you.